Welcome to Boson Buzz, where we dive into the coolest scientific ideas and breakthroughs shaping tomorrow's world. Imagine a robot. You are likely picturing something with rigid arms, whirring motors, and precise, jerky movements. A marvel of engineering, without a doubt, built for a world of perfect order and predictable repetition. But our world is not a factory floor. Place this robot in a collapsed building, tasked with squeezing through a crack to find survivors, and its strength becomes its prison. Its unyielding frame cannot contort, its metal joints would seize in the dust. Send it into the human body to repair a delicate blood vessel, and its hardness becomes a dangerous liability, a miniature bull in a microscopic china shop. For decades, we have been building machines in our own skeletal image, but nature, the ultimate engineer, offers a far more versatile and ancient blueprint. Consider an octopus, a creature of pure muscle and intention, contorting its boneless body through an impossibly small opening. Or the humble slug, a master of its domain, traversing any terrain without a single leg or wheel. Their power is not in hardness, but in softness, not in a fixed form, but in fluid adaptability. The dream has always been to create a machine that can think with its shape, that can become its own tool for any situation. And now, in a quiet lab, that dream has taken a breathtaking, and frankly, somewhat surreal, leap forward. It is not a robot that moves. It is movement itself that has become the robot. This is not a container filled with liquid, nor is it a simple, mindless metal. This is a new kind of substance and a new kind of machine, fused into one, being a symbiotic relationship between material and intelligence. Scientists call it a magneto-active phase transitional matter robot, but we can simply call it the liquid robot. At its heart is a special alloy, often a blend of metals like gallium, which possesses the strange property of melting in the palm of your hand, infused with a fine dust of microscopic magnetic particles. At room temperature, it is a soft, malleable solid, like a metal clay that holds its form. But with just a small, precisely directed increase in heat or a specific electrical current, it can transition, becoming a truly flowing liquid, losing its memory of shape. And swimming within this metallic slurry are billions of tiny iron particles, a kind of metallic nervous system, giving the shape-shifting material a hidden sense. It can hear the silent music of the magnetic world. By applying carefully choreographed magnetic fields, researchers can now not only move this robot, but command its very state of matter. They can make it melt into a puddle, make it flow like a river, make it stretch into a wire, and make it solidify into a gear, all without a single motor, gear, or wire. It is a machine stripped down to its most profound function, the ability to change its fundamental nature on command. The secret to this seemingly magical transformation lies in a silent, invisible conversation between the material and a force field. Think of the magnetic particles within the liquid metal not as passive passengers, but as a vast, coordinated workforce, a legion of microscopic laborers. In their resting state, they are jumbled and disorganized, pointing in every direction, their forces canceling each other out. But when researchers switch on a set of electromagnets surrounding the robot, they create a structured magnetic field, an invisible landscape of push and pull, with hills and valleys of magnetic force. Instantly, like a school of fish reacting to a predator, every single one of those billions of magnetic particles aligns itself with this new landscape. They are all pulled in the same direction or pushed into a specific, pre-programmed formation. And because they are physically embedded within the metal itself, they drag the entire body of the robot with them. To make the robot stretch into a long, thin wire, the magnetic field pulls the particles into a line. To make it form a perfect sphere, the field pushes them into the tightest possible cluster. And to perform its most astonishing trick, melting a different type of field is used, one that turns the particles so violently, so rapidly, that they generate intense internal friction and heat, causing the surrounding metal alloy to liquefy on command. It is a dance of physics, where the invisible dancers themselves become the stage upon which they perform. Witnessing this liquid robot in action is like watching a magic trick where you are shown the mechanism, and it only becomes more wonderful. In one landmark experiment that feels more like a fable, researchers placed the liquid robot at the entrance of a miniature maze etched into a surface. The path was too narrow, too twisted, a labyrinth designed to baffle any conventional machine with fixed dimensions. The robot, a small metallic bead, simply surrendered its form. It melted, becoming a shimmering quicksilver puddle spreading across the starting line. Then, guided by the carefully sequenced pulses of magnetic fields from beneath the surface, it began to flow with purpose. It moved like a living mercury tide, pouring itself around sharp corners, seeping unerringly into the correct pathways, avoiding dead ends with an uncanny, fluid intelligence that seemed almost alien. Within seconds, it had reached the end of the maze, but the demonstration was not over. The true test of its nature came next. The scientists had placed a small, solid barrier across its path, with only a tiny gap at the bottom. In response, the liquid robot simply stretched itself impossibly thin, flowed through a gap mere millimeters wide like water through a sieve, and on the other side, it coalesced, pulling itself back together into its original singular form, whole and undamaged. It had, in the most literal sense, become liquid to solve a solid problem, demonstrating a form of mobility that redefines the very word. The potential applications of this technology read like a catalog of science fiction, now patiently waiting in the wings of our laboratories. Imagine a future where instead of dismantling an entire car engine to replace a single, inaccessible sensor, a liquid robot is sent in. It could flow through the intricate machinery like metallic blood, navigating past pistons and wires, solidify around the broken part, and either repair it from the inside out or carry it out for replacement. In medicine, this technology promises a quiet revolution. A squadron of microscopic liquid robots could be injected into the bloodstream. They could navigate the vast branching network of veins and arteries, a journey of thousands of miles, to seek out a blood clot or a cancerous tumor. Upon arrival, they would transform. They could become a tiny, expanding scaffold to hold a vessel open, a precise net to capture dangerous cells, or even a delivery vehicle that melts to release a powerful drug directly at the disease site, all controlled by magnets outside the body. In the zero-gravity chaos of space, where every gram of cargo costs a fortune, a single liquid robot could be an entire toolkit. Need a screwdriver? It forms one. Need a custom socket wrench? It reshapes in seconds. It is the ultimate multi-tool, reducing the need for countless spare parts on long-duration missions to Mars and beyond. This is the profound promise: machines that adapt to the messy, complex contours of our world instead of us having to adapt our world for them. Of course, a power this profound does not arrive without its own set of intricate challenges and deep philosophical questions. The most immediate hurdle is the question of control. Guiding this liquid metal puppet requires incredibly powerful, precise, and rapidly switching magnetic coils, which are currently large, expensive, and energy-intensive. Miniaturizing this control system from a room-sized lab setup to a portable, perhaps even wearable device is a massive engineering endeavor that stands between the lab demo and real-world use. There is also the question of the material itself. The current metals used, while fascinating, can be soft and prone to wear over many cycles of transformation, and their long-term biocompatibility, how the human body reacts to them over years, is a critical area of ongoing study. But beyond the technical, lie deeper, more philosophical questions that we must begin to consider now. As these machines become more complex, with AI directing their shape-shifting, where do we draw the line between a sophisticated tool and an autonomous agent? If a liquid robot can split into smaller, independent parts to perform multiple tasks simultaneously and then reassemble itself, who is truly in control? The programmer? The emergent behavior of the collective? The very definition of a single, discrete object begins to blur into a swarm. Establishing the ethical boundaries for this new, fluid form of life, however artificial, will be as important and complex a task as inventing it in the first place. We stand at the shore of a new ocean of possibility, and the liquid robot is the first incredible wave, a glimpse into a future where our machines are no longer strangers to the soft, wet, and unpredictable world we inhabit. It represents a fundamental shift away from the rigid, mechanical logic that has dominated our technological age for centuries, a move towards a more organic, more responsive form of engineering. We are learning to speak the language of fluidity, to engineer not just objects, but transitions themselves, the moment between solid and liquid, between one tool and the next. The future this points toward is one of seamless integration, where machines are soft, responsive, and almost biological in their adaptability. They will swim through our bodies to heal us, flow through the veins of our city's infrastructure to maintain it, and journey into alien environments we cannot even conceive of, transforming their bodies to meet every challenge, from the crushing pressures of the deep sea to the dust-filled plains of Mars. This is more than a new robot. It is a new principle, a new philosophy of design. It is a testament to human ingenuity that looked at the solid, stubborn world and saw its limitations, and in a brilliant response chose not to build a better hammer, but to become the water that wears away the stone, that finds every crack, that adapts to every container, and that, in the end, reshapes the world itself. The age of the rigid machine is ending. The age of the liquid is about to begin. If you found this as fascinating as I did, do me a huge favor and hit that like button. Share this video with anyone who loves science or just cool futuristic tech. And of course, if you want to stay updated on this and other amazing breakthroughs, make sure you subscribe to the channel. Thanks for watching, and I'll see you in the next one.